When the Clean Water Act was passed, it became, it was against the law to bang into these wetlands. You couldn't go in and drain them or build in them and so forth without permits. There was nobody knew how to do this stuff, and they put me in charge of violations. Terrible job. I worked for years, not beating up on people, but trying to get people to understand how they needed to do this. One night, three gentlemen came over, a representative from U.S. Steel, a representative from Saturn, and another gentleman that was a developer came over to our house. Judy and I were sitting there, and they knocked on the door and came in and said, Mr. New, you've got to quit this government work and start a consulting firm. We'll keep you flooded with business. You just get out of this and help us. We need help. And Judy and I said, let's do this, and we did, and that's the end of that story. Hi, my name's Jim New. I'm a wetlands ecologist from the United States. I've been down here for 15 years. One of the things we were involved in the United States was using natural systems to treat wastewater. I was trained as a waterfowl biologist, which is really another name for wetland biologist. In the evolution of a private business, we, of course, always preach that wetlands are the kidneys of the ecosystem. They're the ones that filter the water and clean it and so forth. My firm hired some engineers, and the engineers were very interested in wastewater treatment. And so we started evolving criteria to use how wetlands actually work. And it's pretty interesting. Wetlands have a couple of things. They're great filters, of course. They have massive root systems and so forth. But almost all wetland plants translocate oxygen to their roots. And that oxygen is then available to break down carbons, as in waste, if you would. And it's a natural system. Sunlight takes care of the energy involved. So it started evolving a system where you could use wetlands and wetland plants to treat wastewater. So what you'd like to have is a system that has zero carbon in it, with the exception of the wetland plants. One of the things we did early on was had some research done to study wetland plants and see which plants actually translocate oxygen the most efficient, and also which wetland plants translocate evapotranspiration water into the atmosphere. We found this information and then used it in our studies and in our development of wetlands to treat wastewater. We moved to Costa Rica about 15 years ago, and because of the full sunlight, full year, full climate year down here, wetland plants grow continuously, and we decided to put a wastewater wetland here for our residents. The nice thing about the tropics is that you have sunlight almost every day, at least passive sunlight. In the United States, certainly up north where we were in northern Indiana, you have about half the year, or full third of the year, where wetland plants really slow down because of winter, and so the efficiency of the systems is greatly reduced. Therefore, you have to have a much larger system. Now, the systems are pretty simple. You try to figure out how much wastewater you're treating. You'd like to have 7 days retention in the system so that the plants get to work on the water for 7 days. The wetland that we have here is about 700 gallons of water, 700 gallons of capacity. About half of that is rock, so we have about 350 gallons of water in this system, so that we flush the toilet, we'll say at 3.5 gallons 10 times a day from the toilets. That's about 335 gallons a day, and that 35 gallons a day takes about 10 days to get through the system. The water leaving this system, I shouldn't say it's drinkable, because it maybe has some minor pathogens in it, but if you treated it with UV, ultraviolet light, it would be about the cleanest water around. So what we're doing is taking wastewater that would be polluting the streams and the natural systems here, and and we're returning it to the earth in probably as good or better quality than when we brought it into our home. We were the first ones, at least that I know of, to build one in the Golfito area. A restaurant now has one, and several homes have them, and they're working very well. They're very small. We'll show you one in a little bit here. They're quite small, and they can be planted with wetland plants that are flowering and quite beautiful. So it can be not just a treatment system for your wastewater, but additionally a nice view out in your yard. Well, probably the reason a lot of people, I think, aren't using these is just knowledge. They just don't know about them. There certainly are, I'm sure, a lot of people that would like to do a better job of treating their wastewater, but just simply don't know how. So hopefully this video would expose some people to the easiness of doing it. It's just a small rectangle made out of cement blocks and cement. This one's 3 feet wide and 20 feet long, and they're 2 feet deep, actually about 2.5 feet deep, so they have an edge. The bottom 1.5 feet is filled with 1 to 1.5 inch washed river rock, very clean rock. The top 6 inches is pea gravel, 1/4 inch stuff. That's the root system for the plants to anchor themselves. Then they will send roots down into the bigger rock, all those voids in there, and they will completely fill it with a mass of roots. Every one of these micro roots has on the surface oxygen. It's translocated by the plants down to their root system, and that oxygen is what treats the wastewater. It's aerobic digestion. That's the same thing that's used in almost all wastewater treatment plants around the world. Only instead of using pumps and grinders and inflows and all kinds of stuff like that, we just use sunlight in the plants. They do it naturally. And here in the tropics, it's like plants with diesel. They run full-time, hard, day in, day out, 365 days a year. The plants here were taken from habitat around. We borrowed some out of some wetlands nearby. These are natural plants that natively grow here. There's some ginger and some lilies and some other types of plants in here that we have found. I do not know that these are the most efficient plants down here. We have never done studies here, but I can tell you that it works very well because we looked at the water coming out of this system, and it's very nice, very nice. The top 6 inches of pea gravel, the water flows below that, so that there's 6 inches of small pea gravel between the water and the air surface. So there's no possible way for aquatic insects to invade this or utilize it. These systems can be made down here for somewhere between $250 and $350. They're not expensive to do. There is, I should say, a septic system, a septic tank before these. The septic tank, of course, segregates the pollutants. Solids go to the bottom, the floaties go at the top, and then the liquor that comes from the middle of the septic tank is what leaves the septic tank, and that's what goes into the wetland. All right, what we have here is an actual functional wetland. This is in our front yard. It's 3 feet wide, 20 feet long, 2 feet deep, and it's planted with about 7 different species of aquatic vegetation. Gingers, lilies, several different lilies, and some of the lilies are blooming right now. It's quite beautiful. And this is a functional wetland. It takes care of all of our wastewater, comes in this end, has an average of about 7 days retention time before it works out to the far end. All of these plants have the ability, or do, translocate oxygen to their roots. And it's the oxygen, that O2, that's what's that breaks down the aerobic digestion of the waste stream. Instead of pumps, thrashing, air injectors, these plants do it naturally. Sunlight, chlorophyll, and wastewater treatment. Okay, normally in a situation in a home, you have quite a large leach field. You're actually taking the liquor coming out of the septic tank, putting it into pipes that have perforations in them, seeping it into the ground, and you're asking for the oxygen in the ground to treat the wastewater. it's pretty inefficient, and what you're really doing is putting polluted water down into the water stream. With this, what happens is it's treated before it goes out. There's plenty of oxygen in this system, so actually the wetland treats it, and the substrate is rock. There's no accumulation of organics in there. The plants take up a lot of the nutrients, phosphorus, those kind of materials, nitrogen that's in the waste stream, and use it to build themselves. This will be the 15th year that this system has been here, and it should last forever. Remember that the substrate of this wetland is rock. There's no organic matter in there except the roots. Now we do take, at least once a year, come in and clear out a lot of the top vegetation. Phosphorus and those materials that are in waste streams that go into the building of plants can be removed. Otherwise they just bioaccumulate. So we come in and chop down most of this stuff once a year, and then it grows back up very quickly and viable again. Don't chop it all, so we still got treatment. The further north you get in the world, the colder it is in the wintertime, and these slow down. This system in northern Indiana for a home this size would have to be at least 4 times this size. You'd need to have like 28 days retention to break down the waste stream because of everything slowing down. It won't freeze. It never freezes because there's too much biological activity going on, but it does slow down. Well, you know, if you're interested in clean water, returning your waste stream to the environment in clean condition, this is a great economical way to do it. There's no pumps, there's no motors. You build it once, and 15 years later, it's still cooking with sunlight and plants. So anybody that's interested, you could sure get in touch with me. We could draw you up some plans very quick, and or you could talk to several other people around that have done this, and I'm sure they'd be glad to share it. I don't know of anybody that isn't pleased with the results of these systems. One of the things that we did when we were working with these systems in the state was I would take people out that were interested, pull a test tube of the water coming in, pretty nasty, let them smell it and look at it, go to the back end, pull a sample of the waste stream and show them, and of course it's perfectly clear, and show them this material. And I got a nickname of, I always call it Gin Clear, so my nickname became It's Jim Clear, so that's where that evolved.